Hey, this is Mr. Coker with Algebra Lesson 3.1, Solving Quadratic Equations by Vectoring. So, when we talk about solving quadratic equations, that means finding the solutions. And I'm going to just mention real quickly 4 terms that are used, which are synonyms when we're talking about quadratic equations: solutions, roots, zeros, and x-intercepts. The one that should be kind of stick out is x-intercept, because when you graph an equation, a quadratic equation, you can cross the x-intercept either 0 times, 1 time, or 2 times. Because of that, oftentimes quadratic equations will not have one answer. They'll usually have either 0 answers or 2 answers. And again, solutions, roots, zeros, and x-intercepts. You can hear any of those, and they mean the same thing when we're talking about this. So, I'm going to go through 2 equations. Now, these will look familiar, hopefully, in how we solve them. But we'll do one extra step. So, the first one is x squared minus 3x minus 28 equals 0. First thing we're going to do, notice that we have the a value is 1. We have no coefficient in front of x squared. So because of that, we do not have to do the x method. We can go ahead and find factors of negative 28, our c value, and then we're going to find which of pair of factors adds to make negative 3. So I'm going to list my factors of negative 28. Remember that when we do a negative, we're going to have one negative and one positive. And it could be either one. So I've got negative 1 and positive 28, negative 2 and 14, negative 4 and 7, and I guess that's it. So now I'm going to turn it around and do 1 and negative 28, 2 and negative 14, and 4 and negative 7. And we can go through each one of these until we find which pair of factors equals negative 3. This is the pair of factors that adds to make negative 3. 4 plus negative 7 equals negative 3. You can go through each one, cross them out as they do not work, and then until you find the one that does work. Now, remember that when we were factoring quadratics, this is what we would write: x plus 4 times x minus 7. Well, the quantity of x plus 4 times the quantity of x minus 7. And then this is our factored form. When we're solving, what we're going to do is take each individual binomial. Remember that this equals 0. Well, if we set either one of these x's to 0, or if we set x equal to 0, remember that anything times 0 equals 0. So if I set x equal to, say, negative 4, I could do, instead of x, if I put a negative 4 in its place, we would get negative 4 plus 4 equals 0 times negative 11 equals 0. And that's a true statement, because 0, of course, this side, 0 times 11, or negative 11 gives you 0, and that's a true statement. The reason I want to mention this, I kind of want to show that it's evidence, because I'm going to tell you, don't do all this part when you're solving. You should never have to write it in factored form again. And this is why. When we get positive 4 and negative 7, we can now take these numbers. Remember, in factored form, we put them in parentheses. Well, from the vertex form video, when we talked about vertex form, if you remember, we said anything in parentheses, that's a kind of a sign. If something's in parentheses, that you flip the sign. Same thing here. Positive 4 and negative 7, we're going to say that our answer, our final answer, is, instead of positive 4, we're doing negative 4. And instead of negative 7, we're doing positive 7. So x equals negative 4, x equals positive 7. So instead of positive 4, negative 7, those are our factors. Our solutions are negative 4, positive 7. And that is done. Now let's look at one that's looks a little bit more complicated, but really is not. And that is this one. Well, if you look at it, you notice we have an a value that does not equal 1. The a value is 3. That's a sign that we're doing the x method. Remember the x method, up on our top we're going to take a times c, which is 3 times negative 4. 3 times negative 4 is, of course, negative 12. The b value goes on bottom. Well, what is our b value in this equation? If you look at it, we don't have that coefficient, so it is 1. And now we're just going to find factors of negative 12 and see which of those factors gives us the value of 1. I'm going to write this one out in purple. We have 1 and 12, or negative 1 and 12, and I'm going to go ahead and write 1 and negative 12, and negative 3 and 4, and 3 and negative 4, and 2 and 6. That's great for a video. Okay, excuse me. So, anyway, here are our combinations of numbers. We have either negative times a positive or positive times a negative. I'm not going to go through this process of eliminating them again. I'm not going to do that. I'm just going to say that you'll be doing that. And 4 and negative 3, of course, are the two factor numbers. And let's write those on the side. Negative 3 and positive 4. Now what's the next step with the x method? If you remember, this is where we make a fraction and we put the a value underneath. And before I suggested, go ahead and write your x in there. And then we simplify any fractions that can be simplified. This one does not need to be simplified. You check that in a calculator. 4 over 3 simplifies to 4 over 3. It's already done. And negative 3 over 3 simplifies to negative 1 over 1. And that's simplified now. Now, I'm going to write this out just like I did before, just like I did on this side. But at this point, you're about done. And I'll show you why. To do that, I'm going to use this one because if we do x minus 1, remember before that we did, I put both of them together and I said if you can make one of the parentheses equal 0, of course anything times 0 is 0. So if I can set either parenthesis to 0, then that's a solution. Well, this is one of our factored forms. Of course, if I put a positive 1 in place of x, I would get 0. 1 minus 1 equals 0. That's a true statement. It's a check mark, by the way. So, of course, one of our answers then is going to be x equals positive 1. And then the other one, you can do the same thing. 3x plus 4 equals 0. And this is one you can solve the equation. Minus 4 on each side. Divide by 3. And you get x equals negative 4 over 3. I'm not going through how to solve an equation process. Well, do you notice this, that positive 1, negative 1 over 1, what does that simplify to? Negative 1, right? It just simplifies to negative 1. We flip the sign of negative 1, we get positive 1. I didn't need to solve any equation. I didn't have to do that. This part, I have 4 over 3. If I flip the sign of positive 4 over 3, I get negative 4 over 3. I don't have to do this two-step equation. That's kind of the reason I went through it kind of quickly. We don't need to do that. When you're solving these equations, you're solving a quadratic in this manner. Go through the process just like when you were factoring. Find factors of your C value, which add to the B value. Flip the signs. That's if A equals 1. If A is greater than 1, you're going to do the X method. You're going to do the exact same thing, except when you get your final answer, these X's, you don't need them. You don't even have to put these X values in the equation at all. You just simplify your fractions, flip the signs, and you're done. So it's actually a little bit quicker and easier than solving than factoring quadratics. If you know how to factor, you can solve by factoring. Anyway, that's the video, and thanks for watching.